In this lesson, we're going to talk about approximating areas under a curve. When you are given a function and f of x is greater than 0, meaning it's over the x-axis, and you have a closed interval from a to b, there are times in applications that we are going to want to investigate the area of that region that's bounded by the graph and the x-axis. So in this picture, that would be the green shaded area. And a lot of time, it's called the area under the curve, but it's really the area that's bounded by the function and the x-axis. Now, a lot of time, the functions that we deal with are kind of unusual shapes, and it's hard to find an area for that shape. So if we think back about geometry, we have, formulas for finding the area of a circle, for a triangle. We have all these formulas for basic shapes. But when we have an unusual shape like this, we really don't have a geometry formula for it. So what mathematicians have discovered, and this is a lot of the idea behind calculus, if you break things down into smaller and smaller pieces and investigate and examine those smaller pieces, often we can get a really good approximation on things. What we have discovered is if I create rectangles that are the same width, I'm going to try to make it look like the same width, but you just have to imagine that the widths of these rectangles are going to be the same. And so I am creating these rectangles. I do know how to find the area of a rectangle. It's length times width. And so all I would do is I would find the area of those rectangles and then add them up. It would be a little bit tedious to do that, especially since we have a lot of rectangles here. But it's easy to do because we know that the area of a rectangle is length times width. So this is what we're going to be looking at in this section on techniques that we can use these rectangles to approximate areas under a curve. Before we start getting into those techniques, though, we need to do a little bit of review of the summation notation because we're going to need to know that for this section. So summation notation, which is also known as sigma notation, it's a Greek capital letter and it looks like this. And it's used to express long sums of values and short notation. So if I gave you, for example, this notation, this is telling me to start. This is my initial value down here, and then this is what's called the upper limit, and then this is our formula. You want to think of this as a loop in a computer program. You start with that initial value of 1, and because it says let I be equal to 1, anywhere you see I in the formula, you are going to put in 1. Then you go to the next one, 2. Then you plug in 2. Then you go in and plug in the next one, which is 3. And you keep doing that until you get to 20. And that sigma notation is a fancy way of saying now add up all of those terms. So we would take all of these terms and add them up to see what we would get. Now there's a way to do this on the calculator, and I'm going to show you that here next so that you can see how to add this up without having to enter each individual value. Okay, so in order to access your summation notation on your calculator, you're going to choose your math menu, which is over here on the left side of your calculator. You're going to hit the math button, and then you're going to scroll to the bottom, and you're going to look for the summation notation, and you hit enter. Then you can put in your values. I'm going to use X because it's easier and right on my keypad here. So X is equal to, we're going to start at 1. And then our upper bound, we're going to stop at 20. And then we want to just use X. We want to just plug in 1 and then add 2 and then add 3 and do that all the way to 20. Now when I hit enter, it will tell me my value is 210. So that's a lot easier and quicker than entering in on your calculator 1 plus 2 plus 3 plus 4 all the way to 20. So now that we've done that on the calculator, we can write down that our answer is 210. Now, in general, when I write sigma notation for some sum, I should say A sub I, describes the terms that are going to be added. So it's going to be our formula. It's going to be some kind of algebraic expression. And then this down here, the I, that's called our index. And then N is our ending value. And sometimes you hear it called the upper limit. So now you have had a quick review of what all this notation means. Hopefully you've seen this before, and this is just review. Okay, so the first example we're going to go through, we have a couple different parts here. Part A says we're going to write sigma notation and evaluate the sum of terms 3 to the I, and we're going to do it for I from 1 to 5. So for our sigma notation, we're going to write I is equal to 1, and we're going to end at 5. So 5 comes up here, and then the terms are going to be 3 to the power of I. If we were to write the terms out, I start with the first term, I plug in 1, and I get 3 to the first. Plus, and then I plug in 2, so I get 3 squared. And then I plug in 3, and I get 3 cubed. And I plug in 4, and I get 3 to the 4th. And then I plug in 5, and I get 3 to the 5th. Now we can enter that all in the calculator by hand, or we can use the summation notation. If we use the summation notation, remember you go to the math menu, then you scroll down to find the summation, and then you put in at the bottom. I typically like to stay with X just because X on my keypad and it's easy to use. But if you want to use the alphabet variables that are on your keypad, you can go ahead and do that. I'm going to write underneath the sigma notation, X is equal to 1, and then up top I'm going to write 5. And then in parentheses, I'm going to write 3 to the power of X, or whatever variable you choose to use. When I hit enter, I'm going to get a value of 363. Okay, the next example, part B, says write the sum in sigma notation for 1 plus 1 over 4 plus 1 over 9, etc. If you notice, the denominator of each of those terms is a perfect square. So we're going to write it like this. We're going to have I is equal to 1, and we're going to go to 5, because if it stops at 5, that's my perfect square. 5 squared is 25. And I'm going to write this as 1 over I squared. Now, if we check it to make sure it works, if I plug in 1 for I, the first term, I'm going to get 1 over 1 squared, which is 1. When I plug in 2, I'm going to get 1 over 2 squared, which is 4. When I plug in 3, I'm going to get 1 over 3 squared, which is 9. When I plug in 4, I'm going to get 1 over 4 squared, which is 16. And then when I plug in my last value, 5, I'm going to get 1 over 5 squared, which is 25. So this works. And then, of course, you can plug that into your calculator if you want to actually add it all up. Now, in this highlighted box here, we have a list of rules for sums and powers of integers. When we are adding, using sigma notation, a bunch of terms, if we're adding I repeatedly, so 1 plus 2 plus 3 plus 4, all the way up to whatever the value of n is, rather than writing it by hand, or if we don't have that option on our calculator to find the sum for us, we can just use this formula here. So if we were doing find the sum of I from 1 to 10, my n would be 10. That's my ending value. So I would put in the formula 10 for n, and I could find out what that value is. For the next one, if we are trying to add I squared, and we're doing this from 1 to n, we have this formula here. So we just use our ending value for n to plug into our formula. And then if we have a sum of I to the third from 1 to n, then we have this formula here. So we're going to practice using these formulas, and then you can use your calculator to check to make sure it worked. Okay, for part A, it says we're going to find the sum of the terms I minus 3 squared for I is equal to 1 to 200. So what I'm going to do is I minus 3 times I minus 3, so I can square it. So that's going to give me I squared minus 6I plus 9. So I can rewrite this as the sum of I equals 1 to 200, because we want to do this from 1 to 200. It says it in the problem right here. And I want to do that for I squared minus 6I plus 9. Now the properties of summation notation, you can actually split up your terms. I can say I want to do this from 1 to 200 of I squared minus 6 times the summation notation from 1 to 200, and then plus the summation notation of 9 from 1 to 200. So when I evaluate this first term using the formula up here, we're looking at I squared. So according to I squared, the formula is n times n plus 1 times 2n plus 1 all over 6. Since our n is 200, I'm going to plug 200 into that formula. And I'm going to get 200 times 200 plus 1 times 400 plus 1 all over 6. That's the first term. Now if I do the second term, I'm going to subtract 6 times what I get when I find the formula for I 200 times. So I is this first formula, so I've got to take my value of n times n plus 1 and divide by 2. Since n is 200, I'm going to have 200 times 200 plus 1 all over. Now when I do this last term, if I add 9 plus 9 plus 9 plus 9 200 times, that's just 9 times 200. Now when I work all of that out on my calculator, we're going to get 2,567,900. So that's our final answer. Now, you can do that on the calculator. If you have that summation notation option under your math menu, you might as well give it a try and see if you get the same answer. For part B, we're going to find the sum of the terms I cubed minus I squared, and we're doing this for I is 1 to 6. So we have sigma, and we're doing this from 1 to 6, and our formula is going to be I cubed minus I squared. Now, using my properties of sigma, I can split this up into 2 separate summations. From 1 to 6, I'm going to add I cubed. Then I'm going to subtract the sum of 1 to 6 of I squared. Now, looking at this first sum first, I need to find the formula for the sum of I cubed. And that formula is going to be n squared times n plus 1 squared all over 4. So since my n is 6, I'm going to write 6 squared times 6 plus 1 squared all over 4. For the second term, I need to subtract. Now I got to look at my formula for I squared. My n is 6, so I'm going to plug 6 in for n into my formula, and I'm going to get 6 times 6 plus 1 times 2 times 6 plus 1 all over 6. Now, when I put that in on my calculator and do the arithmetic, we should get 350. Now, you can also check this on your calculator if you have that summation notation on there. Now, in the next example, we're going to find the sum of the function values. Now, this is going to lead us into how we're eventually going to use this in approximating areas under the curve. So we're going to find the sum of the values of f of x is equal to x cubed over the integers from 1 to 10. So we're going to set up our summation. We're going to go from I starts with 1 to 10, and we want to cube our values. So we're going to use the cubic formula. So our cubic formula, we got to plug in n is 10. So we're going to have 10 squared times 10 plus 1 squared all over 4. When we put that in on the calculator, we're going to get 3,025.